Okay. Now we want to talk about domains and ranges. Okay, the domain of a function is the set of its x values. If it's y as a function of x, the x values make up the domain. For the basic functions at standard values, the domain consists only of standard values. Okay, so the domain of the basic quadratic just consists of the x values -2, -1, -1/2, 0, 1/2, 1, and 2. And the same, well, no, okay, the domain then, and I don't have room to write it here, we'll talk about that a little bit more when we actually write it out. And this is the only function of the 5, well, actually, no, it isn't. The domain of the cubic function, basic cubic function, is also, you got to point at x equals -2, x equals -1, -1/2, 1, 2, 1/2, 1, and 2. So in both of these cases, the domain consists of all the standard values for the basic functions. So I can write a note here, domain is a set of all your basic values, -2, -1, -1/2, 0, 1/2, 1, and 2. Okay? The domain of your basic exponential function is the same as this except for the -1/2 and the 1/2, because we don't include that in our we don't include -1/2 or 1/2 in our standard. We don't include -1/2 and 1/2 that are in the standard values, but they're not in the domain of the basic exponential function. The basic exponential function has a point here, 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 and here. And to remind you, we don't have points at -1/2 and 1/2 because we don't know how to evaluate the exponential function 2 to the x at -1/2 and 1/2, meaning we don't know how to take the square root of 2, except by punching a calculator, which is forbidden at this point in the course. Okay, so the domain of 2 to the x is the set -2, -1, 0, 1, 2. Not sure what happened there. Okay. Now, the domains of these two functions, the reciprocal and reciprocal square function, okay, what's the domain? Well, we have a point for x equals -2, -1, -1/2. There are the 3 points. And for 1/2, 1 and 2. So that would be the domain. And that's all the numbers in our set of standard values, except for 0. Because 0 is not in the domain, because you can't evaluate these functions at 0. Okay, so those are the domains. Now, the domain of the extended basic functions, and I'm just going to say this now, but we'll see it later in a little more detail. This curve represents the values of the extended basic function. Okay, the purple curve. And we see that the purple curve exists for every value of x. So for any value of x, we can find a value of y from this graph. Okay? We might not find a really accurate value of y, but we could estimate the value of our x squared function at every point. Okay, we could easily do that. Of course, we can easily enough calculate the value of x squared. Point is that every point from -2 to 2 has a y value associated with it. So the domain is the entire interval from -2 to 2. And I think I will actually go ahead and write that down. What I do with my purple chalk. Got another piece of purple chalk here that's a little darker. That's okay. Okay, so I'm going to write the domain as the closed interval from -2 to 2 using interval notation for compactness. There are other ways to write the domain. Okay? And that's the domain of the purple function, the extended basic function. When I wrote this, I left something off, so it's, and I don't want to say it's standard values. I'm going to use the terminology. This is a domain of the basic. And this is the domain of the basic. You can't read that word probably, but it's basic. And this is basic. Okay? This is a domain of the extended basic function. Okay? And the domain of the extended basic function here is also the interval from -2 to 2. So we kind of draw that interval, and I could put a little dot here and a little dot here to show that -2 and 2 are included in that domain. Same here. The domain of the basic cubing function, closed interval from -2 to 2. Now the domains of these functions include all x values except between -2 and 2 except 0. So we write the domain there as -2, 0, union 0, 2. That's for this function and this function. And it doesn't apply to the cubic function. So those are domains. The domains of the basic extended functions. The complete basic functions, well, now the domain of the complete function, x squared function, you can evaluate x squared for any value of x. So the domain, we say, is all values from -infinity to infinity. The same with the exponential function. No matter what x is, you can evaluate 2 to the x. Well, you don't necessarily know how to evaluate, but the value exists. Okay? So 2 to the x, no matter what x you put it in your calculator, it'll give you a result. Well, if the number gets too big, your calculator overflows. But there is a value, and you need higher mathematics to prove that. So we won't worry about it, except to say that the domain, again, is negative infinity, infinity. The domain of your basic cubing function, well, you can cube any number. Every number has a cube, so the domain is, again, negative infinity, infinity. For both of these functions, you can calculate the value of y for any value of x except 0, because you can't divide by 0. You can divide by any other number. So the domains of these negative infinity, 0, union, 0, infinity. That's for this function and this function, extended basic functions. Okay, so there are our domains. We'll talk about ranges, but separately.